I'm Anil Kumar, and here is solution of question number 12, page 307 on properties of vectors. In a trapezoid txyz, tx equals to 2 times yz. If the diagonals meet at O, find an expression for TO in terms of tx and tz. These bold letters are all representing vectors, right? So when you read this, the question is, in a trapezoid txyz, so let me make a trapezoid txyz. So we have something like this, where the dimension of this side is half that of the other side, right? So, and we'll label this. So we have txyz, so that tx is double, the vector tx is 2 times yz, right? So that is tx. So this vector from t to x is twice z to y. So let us say this is z and this is y. txyz is your trapezoid, right? So that is what is given to you. Now the question here is, if the diagonals meet at O's, that means if we connect these 2 points, right? So if I connect these 2 points and the other diagonal here, right? So if I connect these two, then they meet at a point somewhere in between, right? So let us say they meet at O. So if the diagonals meet at O, find an expression for TO, so vector TO, in terms of vector TX and TZ. So that is what we need. So we need to find how the vector TO is related with the vector TX and TZ and TZ. So that is the question for you. So I'd like you to pause the video, try to answer this question, and since my students had a lot of difficulty in answering, here is the solution, right? Now what we will do here is we'll use some strategies which we learned earlier, and to remind you, I'll also give you a link for this particular thing. If I extend the sides, correct, what we are given here is it forms a triangle as if I extend these sides. So when we say that these two sides are in the ratio of 1:2, that means they are parallel, correct? So think about a triangle. So in that triangle, these will form the midpoints. So you are connecting your vertex with the midpoint. Do you see that? So if you are doing that, then what is O? So O is the point where the medians meet, right? So O is where medians intersect. That is called centroid, right? Centroid. And as some of you know, the centroid, the distance from the vertex is in the ratio of 2:1. Now that is the property which you should know to solve this question easily. Otherwise, it is really a very, very difficult question, right? So I'll give you a connection for this also so that you understand. But that's a rule which in coordinate geometry everybody knows, right? So you should know this. You're expected to know this, right? That is how I should be putting it, right? And now we will solve it, right? We did this kind of a question earlier in the previous chapter also, right? So now let's begin and review this aspect, that the point here that is also called property of a regular trapezoid. So in a trapezoid also, it is a property the diagonals meet, then they are cutting at a point which the line segments are in the ratio of 2:1. Now let's move forward. We need to find what TO is. So what we will do first is we'll see, you see this dimensions, right? So TY is what? TY is combination of TZ and ZY. So we'll begin from there. So we say TY, the vector TY is equals to TZ plus ZY. So we say TZ plus ZY. Okay. And we are given that ZY is half of TX, right? So we'll replace that by, so we have TZ plus half of TX, that is given to us, right? Half of TX. So this is given to us, right? So we'll write this as given. This is the properties of vectors, correct? Now, what is TY? Now, as we said, TY could be treated as TO plus OY. So I'll write this as TO plus OY, right? Now we also understand that the ratio of OY and TO is 1:2. So that means TO or OY is half of TO, right? So we can write OY as half of TO. So TO plus half of TO is equals to TZ plus half of TX. Now let's combine these two terms. Half plus 1 is 1.5, or 3 out of 2, right? 3 out of 2 of TO, right? So that is equals to TZ plus half of TX, right? So these are vectors. So we should be either writing them in bold letters or with an arrow on the top. So that's the vector. So from here we can find how TO is related with these two. So vector TO is equals to 2 over 3 times vector TZ plus half of vector TX. Now we can open the brackets. Let me extend on this side. So we will open the bracket and extend it here. So we get 2/3 of TZ plus, when you multiply with this, 2 and 2 cancel, so you get 1/3 of TX. So that is how you can show a relation between TO and TZ and TX. So TO is 2/3 of TZ plus 1/3 of TX. So I hope the steps are very clear to you, and that's how we should be doing it. Thank you and all the best.